All right, I think we are live, I think.
All right, let's see. Let's take a look. Protocol forum. Oh, the live stream's not showing up here. Oh, there we go. And we're live. Awesome.
I think we are.
Nice.
We are live, I think. All right, we are live.
All right, let's see. Cool. All right. Welcome everybody to today's live stream. We're going to be checking out some custom super tokens. And so basically what we're going to be doing is we're going to go over briefly what are super tokens, what are the wrapper super tokens, what are the pure super tokens, and yeah, we're going to jump in and write some code here in a little bit as well. So first things first, what are super tokens, right? These are basically the tokens that allow us to do all of this functionality that you see in the Superfluid protocol. So creating streams, creating IDA indexes, distributions, all of these things, it's all possible with super tokens. Now, originally, the protocol was designed to wrap existing tokens. So your USDC, WETH, Matic, all of these things, basically they were to wrap existing tokens and add this functionality on top of it, right? So you upgrade to this super token, do the streaming, do whatever you want to do, and then you downgrade whenever you're ready. Now, as time went on, and as I and a few other people in the community noticed, you can actually create super tokens that are just super token by default. So you don't have to upgrade or downgrade, they just exist as a super token as they are, which is really, really cool. So the wrapper tokens, you'll hear us refer to them as wrappers. They're a token that have an underlying ERC20 token. So there's an existing token out there, and this is the super version of that. Whereas the pure super tokens, which is what we're going to be building here, is basically just going to be a super token that doesn't need any sort of underlying asset. It doesn't need, anything else there. So, yeah. So what we're going to do, which actually, Sam, did you have anything else you wanted to add there?
No, I think you covered it. I'm excited for this one. This will be good.
Sweet. All right. So we're going to go ahead and start streaming here. Well, not streaming, start coding here. And you can check this out by GitHub. It's fluid-x custom super tokens. And so what we can do here is we'll clone the repo, which I have a terminal set up here. Where you clone it. All right, we're going to pop open a VS Code. All right, so in here, I'll just go ahead and run down the structure very briefly. We have the contracts. So these are a few contracts that I've put together already that allow you to do any kind of functionality you want. They're already pre-built with some Open Zeppelin access control systems and things like that. The base one is going to be the big one. We're going to look through this here in a little bit. This is what's going to allow us to write a lot of really, really cool custom functionality on top of these things. Here we have docs. You don't have to worry too much about this one unless you really like deep diving stuff. But that's talking a little bit about the storage layouts and how the proxy contracts work and all that, which we'll cover in a moment. We have some scripts here that allow you to deploy different tokens. Obviously, you want to change some values for yourself if you want to, create some, let's say, a burnable super token. You want to make sure that all these variables are set to what it is you're looking for and not just the constants. We have some test scripts here, allows us to do, unit testing, make sure everything works properly. And we have, other boilerplate stuff. We have truffle config, so we're going to be using truffle on this one. Now, for this one, we're actually not going to do any actual deployment because that would require provider and mnemonics and all these other kinds of things. And I'm not going to risk leaking any of those kinds of things and, none of that fun stuff. So yeah, let's jump right into these contracts here. So we're going to start at super token base. Now, you'll see there's two things that I'm putting here, super token storage and your UPS proxy. The super token storage, for now, let's just take that as this is the lowest layer of this. It's super low level and very in-depth and technical. If you want to know more about this, feel free to drop a question in the comments or hit us up on Discord and we can deep dive that. But that's a rabbit hole that'll take quite a bit of time for us. Now, the UPS proxy, this is the next one here. So what this is letting us do is basically create a proxy contract. And what this does is it allows your contract to hold state, to hold information, but the logic of the contract actually sits somewhere else. Now, in this case, the logic is the underlying super token, right? So this is like your transfers, your sends, all these other kinds of functions, they exist on the super token contract, right? So if you call, let's say, total supply, you want to check the total supply of your token, what it's going to do is actually proxy that over to the super token logic and then read from your storage. So every contract owns its own state. This is just a way for us to upgrade Superfluid, to upgrade these tokens and iterate very quickly and add new features as the community wants them, right? So again, the UUPS proxy part, that's basically just, allowing us to have an upgradable super token and do other functions like that, right? So in here, we'll see an internal initializer. Now this, you want to call it in the initializer of any super token that you build. And what this is doing under the hood is it's taking a name, a symbol, and the address of the super token factory. Now this is a Superfluid specific contract that handles upgrading and maintaining and all these kinds of things. But we want to pass all of those into this initializer. And that's going to allow us to initialize the custom super token. So this is actually like setting it up so we can have these proxy contracts ready to go. And then the actual super token dot initialize function. Again, if this bit doesn't make a whole lot of sense, just treat it as a black box. This works as expected. And then of course, if you want to deep dive that in the future, feel free to ping us.
I have a request to jump in. Do you mind turning the lo-fi beats down just a hair, just a little bit?
Yeah. Gotcha.
For the sake of our viewers, a little bit. Yeah.
There we go.
That's better. I didn't want your voice to be drowned out by the background.
Yeah, for sure. But yeah, so just briefly recapping here, this internal initialize function, you want to call that in the initializer of any super token that you build. And that's just going to make sure that it's set up with the factory so that it can be upgraded, as upgrades and updates happen. And you want to call the super token dot initialize, and this handles some other boilerplate logic. Again, not going to go super in depth on that one unless somebody asks. Now, a few other things we have here. We'll have an internal total supply that we can read. Now, all of this stuff here, this is just a very thin layer of abstraction on top of everything else that we're doing. Really, it's just a way to make sure that we can actually hit the proxy contract and call the functions that need to be called. So we have a total supply. This will get us the total supply of our super token. Mint, of course, allows us to mint tokens at will. Burn, pretty self-explanatory. You can burn tokens. You can do approve and transfer from, right? So again, all of these things already exist on the ERC20 interface. Well, maybe not mint and burn, but the extensions do, right? But what this is allowing us to do is basically write our own logic. Maybe we want to have some special function that conditionally mints a few tokens here and there. We can actually use this internal mint function. So we'll go ahead and create a contract, and let's call it any mint, because we're going to allow any address to mint, because why not? So any mint super token dot sol. Okay. Oops. I'm going to set the GPL v3 license because is best license for open source. Not financial advice. We're going to set the Solidity compiler to at least 0.8. That's just going to give us some more modern functionality. Okay. Any mint super token. And we're actually going to make this, let's see, what's it called? Super token base. All right, so this is the super token that we were just taking a look at, the base contract, right? So this allows us to, write any custom functions in here. So first thing we want to do is we want to set up the initializer. So we're going to say initialize. Now in here, we're going to take a name. We're going to take a symbol. And I think that's all we need. Oh, the factory. Okay, we'll make that external. Oops. All right. Now, as you saw before in the super token base, I'll actually clip that. Let's see if we can put, whoops. Hold on. There we go. All right. So we have the internal initialize, which we'll call right here. Now it's going to take the name, symbol, and factory.
One thing to mention here, actually, guys, is like for those of you that aren't familiar with the proxy pattern, like the standard UUPS proxy pattern, there is no constructor, right? You need to use an initialize, but effectively serves as your constructor. So just one thing to mention there, in case you are unfamiliar with the syntax.
Right. Yeah. So the initializer is where you're putting all the initial logic, you know, in the case of something like a proxy contract. And that's just the way that, you know, these things are set up. It's also good for things like when you're deploying, you know, a contract from another contract and you have factories and all that kind of stuff. That's definitely going to help. So we have our initializer set up. So we take the name, symbol, factory, all that's good to go. Now we want to basically allow anybody to mint. So what we can do here is create a public mint function, and we'll say, actually, let's make it a set amount, right? So anybody can mint, but they get a set amount. So we have mint external, and yeah, let's give it an event. That way we know, you know, when something like this is happening. So mint, it'll have the minter address, and it'll have the amount. Why not? All right, so we're going to use that, and we're going to call it in here. So first we want to use mint, which we'll see. It takes an account, it takes an amount, and it takes user data. Now the user data is ERC 777 specific. Well, that's where the inspiration for it came from. But basically what that does is, let's say a contract goes to mint. If that contract is an ERC 777 or a super token recipient, then we can actually execute arbitrary logic based on that. So we can encode some arbitrary user data. That contract can go and take that data and do something really cool with it. For this, we're actually not going to do that because it can get pretty complicated with that. So we'll keep this one pretty short. But in here, we'll have the mint. Now we're going to mint to the message sender. We're going to mint the amount, which let's just call it 21, because why not? And the user data, we're just going to make it OX for now, so 0 bytes. Then inside of here, we'll emit the mint with message sender, and let's make that a constant. Yeah, cool. I know it's kind of redundant having a constant and then separately putting it in the event, but yeah, this is just for show. But yeah, so this is pretty much it. So you can add, you know, any functions here that you want. You know, if you want to add maybe some other arbitrary logic, doesn't necessarily have to be mint or burn policies or anything like that. You can pretty much add any of that stuff, you know, right in here, which is really cool. And so, you know, like I said before, because this is a proxy contract, any of these super token methods that you're used to dealing with, right? So the you know, your total supplies, your balance of, transfer, all these kinds of things. It's not going to exist on this contract per se. Sorry, 1 sec. It's not going to exist on this contract per se. What it's basically what it's going to do is it's going to run through. It's going to see, okay, there's no total supply here. So what we'll do is we'll actually proxy this off to the super token contract. This is what Superfluid's created. And it'll run that logic, right? But in the case of, let's say, mint, right? Mint does not exist on the super token, you know, interface, like what Superfluid's built. What that'll actually do is it'll run through and it'll see it on this super token, or sorry, on this contract. And then it'll say, oh, okay, we have a mint function here. No need to proxy this off. We can actually just use this right here as is. So this is pretty much it. Like I said, it's going to be pretty minimal here, and we'll create a little deploy script. So we'll call it any mint. All right. Cool. So we're going to do a few imports. Actually, no, I'm going to copy paste it. Not going to take the time to do that. 1 sec. One thing we are going to need to import is going to be the AnyMint super token. Now, again, this stuff is in a truffle environment, so it might not be entirely entirely familiar to you, but it's not too much different than what you'd see in a hard hat instance instead. So actually, we're going to just copy the bulk of this and just gut it. All right, we'll keep these guys. And we'll get rid of these. All right, so this is the boilerplate that you're going to see, in pretty much any of these things. So we'll have an async function. It's got a callback. This callback is good if you're trying to like verify, in the same script call. You can add some plugins and stuff like that. That'll be super helpful for it. Here we have. Well, I should probably hold on. Yeah, so here we can set a Web3 provider. Right, so this is basically going to inject the Web3 instance into this script for us. Here I just set up some convenient stuff just to make sure that we can get a hold of the chain ID properly. So these are the different factories on each network, right? These are the super token factories themselves. And remember, we actually need that whenever we call this initializer here. So we got all that in place. So we're going to deploy it. And we're going to use the Web3 TX. This is something that was created by decentral.ee. It's basically just a little bit of a convenience thing. It's really good with the console logs, helping out and all that kind of stuff. So we're going to take this. We're going to create a new instance of it. And as one of the convenience things, we can actually say like what's happening here, right? So we're going to say deploy AnyMint. Okay, then once this is all good, we'll actually console log. So we'll just say token deployed to this guy. Cool. And so what that's going to do is once the transaction runs, it's going to grab the address and print it out for us. Of course, if you wanted to do something else with this address, right? Like maybe you have some other functionality or something else you want to pass that address to, you can always do that right here in the same way. For now, we're just console logging it. After this, we need to run that initialize, because remember, it's not enough to just deploy, we also need to initialize, because that initializer is not part of the constructor. Okay. So we're going to call this contract. This is the contract that was just deployed, right? Let's call it that, just so it's a little less ambiguous, right? So this is the deployment of the contract using artifacts require. And then this little bit right here is the actual contract itself. So what we'll do is we'll call initialize and we'll say, initialize AnyMint super token. And then here's where we're going to put the parameters. Now we have name, symbol, factory. Let's call it, I don't know, super mega ultra token, because why not? Okay, and we'll give that sim ut. Oh, maybe not smut, that's bad branding. Yeah, super mega giga token, there we go. Don't worry about it.
Yeah, I think the ticker symbol, guys. Boys and girls, think of your ticker symbol when you're
think of your ticker symbol. All right. Yeah, so this is where we're extracting the super token factory address. Remember, we saw that in constants here. So whatever network we're running this on, it'll automatically extract it and put it right in here for us. So again, just a quick recap on this. We run one transaction which deploys this contract here. And then we run a second transaction that calls this initializer. And what this does into the hood is it upgrades it with the super token factory. So it makes sure that, it's up to date. It's got the latest and greatest code. And then it does the super token initialize, which again, that's something that was defined by Superfluid, but it's just a way to make sure that, all the proper initialization data is there. So the name, the symbol, the decimal numbers, all that kind of stuff, all that gets set up right inside of here. So super convenient, super simple way to get this all set up. And then what we can do now that this is initialized and now that everything is good to go just say like custom logic in here. So what we can do is we can take just some arbitrary address. I'm just gonna grab one out of here. This is the, what is this? I think it's like the first address that gets generated in Hardhat. So no alpha leaks here, no secret addresses here. But what we can do is with this super token, we can say, wait, super token dot mint. Cool. Let's actually do it the Web3TX way. And we'll just say user mints. All right, cool. So this alone, this is something that we would have to, since this is the person that's going to be calling it, we'd want to basically set this up in the .env and set it up in the truffle config. Again, we're not going to go super in depth into that, but this is in a nutshell how you can run these transactions now, right? You can call any of these functions directly on it. There's a few other things that you can do to basically merge some of that logic of super tokens and other things in there. So it's a lot more convenient to call it from JavaScript, but I don't think we're going to go too in depth on that today. I don't want to go too deep into that, but does anybody have any questions or anything they'd like to mention here?
Doesn't look like we have anything directly from the chat. However, do you think it'd be a good idea to show any of the other experimental contracts or walk through specifically how to actually go through the process of deploying an ERC20 wrapper on a Block Explorer?
Yes, let's do the deployment first, then we'll check out some of the experimentals. So what you can do is you can head over here to docs.superfluid.finance, and you can work your way over to network directory. It's over here on the sidebar. And for basically any network that we're deployed on, we can go and find this here, the super token factory.
Before you go through this though, Joshua, one thing, so what we just went through there, what Joshua just went through there, is a really easy way to create your own custom logic with super tokens, which is great for anything you want to deploy that's native as a super token, right? So we have some super tokens that don't have any underlying ERC20 address associated with them in our community. So for example, there is a DAO in our ecosystem that we love called Ricochet Exchange, who has deployed their main governance token as a native super token. That means that there's no underlying ERC20 assets underneath the main super token functionality, right? It's just a super token through and through. What Joshua just showed you is how to deploy your own versions of that, which can have all of their own custom functionality. But we know that interoperability is extremely important in our space. So you can also create a wrapper contract for any existing ERC20 token you want to use within Superfluid. So if you go to our docs here, like if you scroll down, Joshua, you see here these examples of tokens, right? Where we have the FDAI and FUSDC. These are just fake tokens we've deployed for test nets. So you can play with this in all of your testing. But you can see there we have like FDAIX, FUSDCX, FTUSDCX. The X bit there at the end denominates that it is a super token, right? So the FDAIX contract is really just a wrapper around FDAI, right? It's a wrapper around DAI. So on mainnets, it's just called DAIX, which is a wrapper around your standard ERC20 DAI. Now, if you have any ERC20 asset you'd like to wrap, it's extremely easy to wrap that token by going to a Block Explorer and calling a simple function on Etherscan. You could obviously do it if you're a developer. You can write code to do this if you want. You can get the ABI for the super token factory and get the address for it and do it yourself in a script. But what Josh is going to show you is how to do it in a Block Explorer. So show us how to do it, Joshua.
All right. Yeah, so we can hop onto super token factory. Again, this is for any network that we're deployed on here. And so what we can do is we'll see, first of all, just as a quick little aside, you'll notice this is also UUPS proxy, right? So it's doing kind of the same thing here, allowing you to proxy and upgrade and do all these other really, really cool things. I won't go super in depth on that, but we can see here, these are the logic or the logic functions that we can call. And so in this case, we have, looks like we have two of these. Yeah, okay. So I think this one is for weird decimal things. But yeah, what you can do here is you can actually punch in the underlying token address here. You can put in the upgradability, and you can put in the name and symbol. And so we can go in here, let's see.
By the way, Joshua, I think in the last example, the reason why there's two is we use the overloading pattern to allow you to call it with decimals amount if you need to, but beside the point.
Cool. And let me just double check the docs here. Make sure we put the right upgradability.
And again, instructions here in the docs for this. You can go to the super token section of the docs, and here in this create token from block explorer section, you can just get the direct instructions for doing this.
Yep, so it looks like one is the way to go on this one. So what we can do here is we'll punch in the underlying token. So this, in this case, this is our FDI. This is the ERC20. And this can be any of your ERC20s, right? So you bring your ETHX or, Bitcoin, your wrapped Bitcoin, anything like that. You can punch that in right here, and that'll upgrade for you. Upgradability, as I said in the docs, we'll set that to 1. Now this is FDI, right? So we'll just call it super FDI. And as the symbol, we'll say FDI X. And so as convention, we have X at the end of the symbol to indicate that it's a super token. And then we have in the name, the word super is before it. And so we could do that. Again, not going to call this because that already exists and we're on testnet anyway. But yeah, so that's how you'll do these kinds of upgrades here, right? You can find all this stuff here in the docs. And then in terms of the custom super tokens, we'll actually be sure to link this in the Discord so you can check this out as well. But this includes pretty much all the instructions you need. It includes some notes as well on basically how all the different things work, what they're supposed to do. So feel free to check that out anytime.
Awesome. One last thing that actually comes up quite a bit is native asset super tokens. So as a recap, I just went through the explanation, and Joshua just showed you how to deploy custom super tokens. We also just showed you how to wrap an existing ERC20 asset so you can use that as a super token. But a question we get a lot is, how do I use a native asset as a super token? So if I'm on Matic, how do I use Matic as a super token? How do I stream this native asset? If I'm on an ETH testnet, how do I use ETH in a stream? And it's tricky there because there's no underlying ERC20 address, right? And you don't really want to, you can't deploy a contract necessarily you can't deploy a contract to directly represent ETH, right? So how do we stream that? And the way this works is there actually is a separate contract called Super ETH or CETH. You can find that in our repo, but you can also find it in our docs. So Joshua, if you go to our docs, I can show people where to find this in case they want to understand how this works. If you go into the interactive tutorial section, into using super tokens, we have a simple example that walks through the upgrade process for a standard ERC20. And we explain how native super tokens and wrapped ERC20 tokens work here. But we also explain how native asset super token works right there. And then if you scroll all the way down to the bottom of the page, you will see an example of how to actually upgrade a native asset, right? So what's happening there is you are deploying the Super ETH contract and calling a function called upgrade by ETH on it and passing in message.value of whatever the amount you want to upgrade is. So it's extremely simple to work with these once you have the contract deployed. For all the Ethereum testnets and for Matic, these are already deployed. So all you need to do is go to the network directory that Joshua was just looking at, grab the address, get the ABI, and go from there. But in the future, as Superfluid is deployed on more and more chains, you might have a desire to maybe deploy your own Super ETH contract, right? Which can be repurposed for AVAX if Superfluid's ever on Avalanche. It can be repurposed for Phantom if Superfluid's ever on Phantom, right? It's just a way to wrap the native asset and use it within Superfluid more broadly for streaming and with the IDA. So I just want to call that out because that is kind of the final type of super token that we didn't really discuss yet. So yeah.
Cool. Thanks. Yeah, so unless anybody has anything else, I think we can go ahead and wrap it up here.
All right. Well, Fiddy gave us some good feedback. Fiddy said it's good stuff. Thank you, Fiddy. We appreciate your participation in all of this stuff as always. And if you have any questions, drop us a note in Discord. We will make sure that in this video's description, we have a link to the repo we used today and a link to this section of the docs on using super tokens so that you guys can refer back to it. So go thank Joshua for putting together that repo. That was his work for putting all of that together. Hopefully it's helpful to you. And yeah, we're here if you need us. Cool. All right, guys. Well, have a good one. Thanks for joining us.
Have a good one, everyone.